Hello, and welcome to this presentation to Cloud Strategy and Insurance, Finding the Right Cloud Model, something somewhat trickier than one might imagine. My name is Craig Beattie, Senior Analyst with Celent. Cover typically non-life systems across EMEA, but been covering technology across insurance for well over a decade now with Celent, and for more than 20 years beyond that. So first I'm going to talk a little bit about some of the cloud models, some of the cloud providers, some of the key trends. Spend maybe 5 minutes on this. And then get into the nuts and bolts of some of the cloud models and some of the differences. Then spend a little time on the trade-offs. Sadly, I don't have any answers for you, but hopefully I can help direct you to the right questions. But first, as a service models and their adoption in insurance. So we pull out three key ones here, ones that have been discussed now for nearly a decade actually. The first one there, infrastructure as a service, being able to pull compute, storage, networking capability, being able to draw that programmatically, talking to machines, getting it automatically delivered. We've also been talking about platform as a service, so a platform there being something that allows other applications to be built, typically a higher level capability than infrastructure as a service, often, although not always, built on top of infrastructure as a service as well. So examples of that would be Force.com, for instance. One could argue that some of the serverless models are a platform as a service model as well. So finally, software as a service. Now this is much more, it's kind of the application plus platform as a service and the infrastructure as a service. Examples here, the obvious one, the one that comes up most of the time is Salesforce. But really these are applications that exist in the cloud. You don't need to install anything, you simply sign up to them, set up your configuration, and you're off and running, you start using them. So there are applications that exist as a service. You sign up, and typically there's a commercial model that matches that as well. Now, if we look at public cloud more broadly, there's a whole suite or a whole set of different sets of capabilities that are available out there. Some of the public cloud offerings offer contact center capability. Most of them now offer AI analytics capability. Many of them have different variations on databases and other data storage capabilities, including, but not exclusive to, big data capabilities and data lakes, that sort of thing. Single sign-on. The security stuff is becoming quite harmonized across the cloud providers. It's sort of the low bar in terms of adoption. And then of course you can get different types of chips as well in terms of some of your server and maybe even bare metal requirements on the infrastructure side as well. So it's a huge gamut. Not going to cover all of this here today. This isn't really the objective, but it's just an observation that cloud providers, particularly the public cloud providers, are growing in capability and delivering more functionality and actively competing with each other as well. This, if you like, is what the internal IT departments are up against. This is the level of investment we're seeing from the big players. Can a small business or even a medium-sized insurer keep up with this level of investment in their infrastructure? Some key trends in here in terms of public cloud security, rise of cloud access portfolio. I mean, the level of investment is extraordinary, and the public cloud providers are starting to branch out of what you would typically consider public cloud into IoT solutions, AI, as I mentioned, machine learning, that sort of thing. Hot topics there. And there are some platform as a service plays as well coming from the cloud too. So lots of really interesting things happening here. And actually what we're seeing is the insurers are increasingly looking to adopt these. These, as you can see from the years here, 2018, 2019, we were looking here at figures before coronavirus and the COVID-19 outbreak, which we're hearing is accelerating some of the adoption of this digital technology. But you can see already before that there was a marked increase, and actually from 2019 through to the end of 2019, we were seeing increased interest and adoption as well, which is very interesting. But let's get into the meat of this a little bit. So naming the core system deployment model. So let's take a look at how people are delivering and deploying and running insurance core software now. And we're going to dig in a little bit into the whole nomenclature around cloud native and try and unpick that a little bit and give you some tools to think about some different models for cloud native. As I said, we'll finish off with some of the trade-offs so you can get some idea around what the key questions here are. I'll try and talk a little bit about availability of some of these models as well, so that you can get a sense of not just what's the right model for you, but also what's the right model at the minute, and actually what's coming down the track as well. We'll talk a little bit about that too. So, differences between cloud-enabled and cloud-native systems. I mean, lots of discussion around this. I'll talk through this briefly, but I think I want to dig into some of the definitions or sort of stretch out this cloud-native concept. But if cloud-enabled, cloud migrant, there's a few different terms that have been used for these sorts of technologies. So these are technologies that came pre-cloud, were built beforehand, and have moved into the cloud, but haven't fundamentally changed yet. So really taking something that was not built for the cloud, shifting it into the cloud and starting to use some of those capabilities. Cloud native tends to talk more about something that was designed post-cloud, a bit like digital natives, people who grew up after the rise of the internet, Wi-Fi, smartphones, that sort of thing. They behave and expect different things than people who grew up before that. And actually systems that are built, designed, and conceived after the cloud was enabled or cloud came into existence. And actually we could talk a little bit about how cloud in 2012 was very different to cloud in 2018. But the idea is that once you start thinking about software-defined infrastructure, once you start thinking about platforms as a service, about not having to worry about the underlying scalability or a different set of rules around scalability, shall we say, you start building systems differently. So a few key categories here. So in terms of design, cloud enabled, you modify systems that were designed to be locally hosted. But actually with cloud native, you're designed to be deploying in the cloud using microservice design patterns. Out of scope of this, but we can certainly discuss microservices at another point. No modifications needed to get into the cloud. One of the key issues around cloud enabled and actually moving from this premise that you're going to define the infrastructure, define the operating system, define the versions of the application servers, define the versions of the databases that you're going to be running in. There are lots of assumptions there around the amount of control you have over the infrastructure. Actually, if you move into containers, so a container is a way of specifying an application and packaging it up so it can be deployed in something that can execute a container. But there are constraints then in terms of you don't know some things around the operating system. There are things that you can't do. The container is a container. It's something with walls to it, virtual walls, shall we say, but stops you doing certain things. So there are certain constraints around running things even within a container, such as Docker, Kubernetes, that are different to running on a physical system. So you have to make some considerations in order to do that. And actually, if you're shifting into platform as a service, if you're shifting into some of these other models, the constraints are tighter again. Now that doesn't mean that they weaken the proposition, but if you're moving from a place where those constraints didn't exist, there is an investment required in order to adhere to those. In terms of scalability, so maybe you're limited to server capacity or require specific configuration to scale. So there's lots of work that was done back in the 2000s and early 2000s, thinking about .com, web scale, and then we got into big data scale and that sort of things. So lots of interesting work being done there. and lots of things that we understood around how to build applications so that you can horizontally scale out some of that infrastructure. But again, in an environment where you can define, you can use software to define your infrastructure, where you can get hold of compute relatively easily, it's a different kettle of fish. It's a different paradigm that you're looking in terms of scalability. I think for the cloud native, performed automatically is maybe a little misleading, but that's broadly true, right? You can build something, write it with some scripts, some JavaScript scripts, put it somewhere, and it will execute. And actually, it will execute a great deal. You can write bad things and pay more money for that, or you can write good things and pay less money. But the scaling kind of comes for free, depending on where on the tiers you are. And then maintenance must be customized to the installation environment, may require a specific configuration. So again, talking there about actually how do you put the machines together. But actually with cloud native, the idea is it's a bit like installing an app on your phone. The expectation is that it's up to date. Evergreen is a phrase that I hear. And this is different between cloud services and installed software that you're buying. And then redundancy. Again, there are some things you can do to break it, but broadly, if you're cloud native, capacity is always available. If you write really bad code, you can breach that. There are things that are intractable, unless you've got a very, very large wallet to spend on some infrastructure. But broadly, capacity is always available, versus actually you have to plan this out. And actually, one of the key challenges around this is if you're deploying on-premise in your data centers and you're concerned that you might lose some of your infrastructure, you have to have a second set of infrastructure standing by, being maintained, being looked after, so that you can bring up that environment again. And that just isn't necessary in a cloud environment, right? That you're not worried about the servers and that sort of thing. So whilst in some cases on-premise can be cheaper, actually because of the business continuity planning, something that has been getting a lot of attention recently, and some of the ways that you're doing some of that backup planning, actually you can be paying for infrastructure that you're simply not using, which is perhaps a challenging environment. So, some quick differences there, but let's dig into this a little bit more. So, here we have some on-premise models, some cloud models. We've split it up into 8 because I think there's some key differences between each of these. So I'll go through them briefly. So we've got on-premise legacy, very slow. Now this is the kind of the big systems. I'm going to mention some types of systems. I'm not saying the systems themselves are legacy, but typically if you find systems built in assembler, COBOL, that are dated more than a couple of decades old, those tend to be legacy systems. And that's kind of what I'm talking about here. There is a view that legacy actually describes a set of systems that no longer contribute to or in some way inhibit what the business is trying to do. And that's a very broad definition of legacy system. I'm thinking here in terms of this one, the kind of on-premise legacy. Actually, we're talking about something that's old, shall we say, and actually can't shift into the cloud, or it's very, very difficult to shift in the cloud. Then we've got on-premise, and this might be a more modern application, but again, it's installed on-premise and it's running on-premise. I haven't pulled out hybrid in this case. Typically, once you get to a concrete deployment, it's either on-premise or it's in the cloud. We'll talk a little bit about that kind of multi-hosting a bit later on, but not on this slide. So we've got on-premise. And then we move into hosted in the cloud. And actually I see very little difference between on-premise and hosted in the cloud. Hosted in the cloud typically is just about getting the right infrastructure, setting that up appropriately, and almost treating it like a server that exists in the data center. Software-defined infrastructure is now not limited to the cloud. It's something that people can do within their own data centers. So actually that idea of hybrid cloud, the idea of significant differences between how you host something internally, how you host something externally, a lot of those barriers are taken down. But by hosting it in the cloud, even if you just take the compute, the storage, that sort of thing, you no longer require a data center for that, actually. So there are some significant differences in terms of financial investment, in terms of maintenance and that sort of thing between 2 and 3. But actually, in terms of the structure of the application, very, very similar. In terms of user experience, very, very similar again as well. Now, we draw into something that I've called enterprise cloud native. So for enterprise software, there tends to be a set of assumptions around it in terms of, so this is software defined in order to be used by a large organization. And in order to do that, there's a lot of things around access control, around user ID management, around audit, around regulatory controls, all that sort of stuff is kind of built into that enterprise. And it exists in the other tiers. But what you tend to find is that these are big systems that have been around for a long time. Some assumptions have been made about how you need to build those and deliver them. And actually how you bring my cat has joined me. Anyway, so how you have to bring those into a cloud native environment. So there's something interesting about that. Sometimes it's microservices enabled. Sometimes it's using containers and Docker. Typically, though, it tends to be a blend of a few different things, actually. So the services, the size of the applications tends to, you get small, medium, and large in there, and that sort of thing. And also, it tends to be something that's been migrant, a cloud migrant environment. We'll dig a little bit more into that, I think. I think it's worth talking about number 4 some more. So, open source cloud native. There are a couple of models. The most popular I've come across has been the Cloud Native Computing Foundation. And a few of the folks I've spoken to said I should have mentioned that explicitly within the report that we published. So I'll mention it explicitly here. Do have a look at that, cncf.io, I think it is. So the open source cloud native, so that particular interpretation of that is very much a Linux-led, Kubernetes-led set of standards around building something using open source capabilities that can then be deployed in a number of different cloud hosting environments. So it can Kubernetes seems to have won out as one of the container environments that most people are using, and actually you can deploy that to Amazon, Azure, Alibaba Cloud, Google Cloud, and one assumes Oracle and others as they come up. There's a set of constraints around how you build the applications there, and given the name of this one, some assumptions around some of the use of the open source tools that you're going to use. But one of the interesting things, and we'll dig into this in the next couple of slides, is it's deliberately decoupled from the cloud environment, actually. So it's something that's cloud portable, if I can use that phrase. So it supports a multi-cloud strategy. Now, as we move up, we're going to be increasingly more cloud tied, actually. So let's start with an initial cloud tied. So, and this can be something that's been cloud migrant. It's been moved from another part of the environment. It can be something that's open source cloud native as well. But the distinguishing feature between 5 and 6 is that 6 is tied to a particular cloud. Now that might be because it's using the call center capability of a particular cloud provider. It's using the AI and machine learning libraries from a particular cloud provider, so it's not decoupled from them at all. Maybe it's using their API management tiers. It's using something that's very specific to that cloud, and it only now works in one of those clouds because of the way it's deployed. Now, I think 1 through 5 is cloud agnostic quite frequently, but 6 is where you start to say, actually, we're going to go deep with a particular partner here. Now, some of the insurers that we've come across where they wanted somebody to come to them with a cloud proposition or a software as a service proposition have wanted the partner to deeply understand the environment that they're deploying to. As you'd expect, right? If somebody was selling you a car, you'd want them to really understand the nuts and bolts of what's happening in the car. Somebody's selling you some cloud software, you want them to understand the nuts and bolts of the cloud software. and actually being cloud tied and deeply coupling in there, making great use of the facilities of that particular cloud is a great way of demonstrating that. Much more difficult for a medium-sized or even a large vendor to demonstrate expertise in all of the cloud providers out there. But we'll come back to that one. It's an interesting one. So that's the key distinction between 5 and 6, right? So 5 is still cloud agnostic, could be in multiple clouds if you wanted to. There are some challenges there, and we'll come back to that. But not tied to a particular cloud. 6, definitely tied to a particular cloud, and actually probably marketing on it, right? We are experts in this cloud that we have chosen, and we're using some of these differentiating facilities from this cloud in order to augment our software. A step further beyond that, serverless applications. So this is something that's come in more recently, I think. So serverless tends to rely on being able to put some compute in there, some code, something that's going to happen and execute in an environment where you don't worry about the server. So if you have a microservice and it's in a Kubernetes container or just some other deployment paradigm, you still kind of have to have a server, and you've got this idea that the thing that you want to execute goes in the server, and maybe I scale it up to multiple servers or I just have one server, but there's still this idea of I'm managing a server and an environment that's going to execute my code. Serverless takes that away, actually. The idea is you put the code somewhere and then you trust the platform underneath that, and this is more of a platform as a service kind of play. You trust the platform underneath that to execute that code in a way that so it's consistently executed. You don't mind where it gets executed. It's not storing, there's no state in it, and it's just going to get executed. So there's no server, if that makes sense. There's no idea of deploying some infrastructure or asking for a 2 CPU machine or a 4 GPU machine. Something somewhere is going to execute it. Now at the moment, there isn't, I'm going to make a broad statement here, there isn't typically a serverless environment that's cloud agnostic. If you want to go serverless, you're probably writing Azure Functions or you're writing AWS Lambda. They are different things, and if you wanted to use both of those, you'd be writing different stuff with different tools, different languages. So that's one of the key differences here. Much more deeply cloud tied now. Deeply embedded in a particular environment, a platform if you like, but there are some advantages to not having to worry about configuring the rest of the infrastructure. So a key difference there again from certainly enterprise cloud native and some of the open source stuff. That open source cloud native, the CNCF definition, very much you're managing containers sit in servers, and that's the paradigm that you're thinking about. Serverless, I've got some compute that needs to be executed and it goes somewhere. And an extreme cloud native. We'll come to it more on the next slide, but really trying to express that deeply tied into a particular environment, typically embedded in a platform, might be making use of serverless but doesn't need to. It only works in that cloud. It can't be decoupled. So this is deeper than cloud tied, right? This is it only works in the cloud. It only exists because that other platform exists, and actually it's typically augmenting some of that. So some examples of this might be some of the applications in insurance that have been built on top of Salesforce.com. Talking about that again, but also some of those that are tightly coupled in there. There are examples of insurance software applications that are integrated to Salesforce.com and can work beside it, but there are some pieces of software like Velocity, like Novadeya, that are deeply embedded into the Salesforce cloud and simply wouldn't work or exist outside of that environment. There are other examples of applications that exist within a particular ecosystem, but at that extreme cloud native end of the scale, typically they are participants in an ecosystem and only work within that ecosystem rather than being something that defines the ecosystem. We can talk a little bit about that as well. So, cloud native computing advantages. To be honest, in order to get into cloud native, you have to have got, maybe this would be better as a pyramid in some ways, but you have to have got a number of foundational concepts built up in order to start deploying this way. And actually, this is true if we go back for that kind of enterprise cloud native. This is maybe a good distinction between just taking something that was previously built and works and then shifting it to being hosted in the cloud to something that's more enterprise cloud native. I'd say that 3, some of this stuff is optional, but 4 is absolutely necessary. So let's go through these. So we've got the idea of DevOps. So I mentioned software-defined infrastructure quite a lot. Certainly very important in infrastructure as a service, very important in the cloud. But DevOps really pushing there for automation within IT. So building IT assets that make IT better, if that makes sense. It's a concatenation of development and IT operations together so that you're improving the throughput of change predominantly, but actually you're automating a great deal, automating testing, automating the infrastructure delivery, that sort of thing. And then getting into continuous delivery. Many of us, the CI/CD pipeline, so continuous integration was something that was around, 15 years ago, something like that. It was a very brave few of us who were doing continuous delivery 10 years ago, but it's certainly much more possible now, much more capable now. Many of the tools delivering that. And continuous delivery is about you make a change, you automatically test it, you automatically deploy it in your different environments and do the integration test to make sure the code works where it's going to work, where it's going to work. And then, if all of those tests pass, you're straight into production. And actually, this is where that kind of evergreen, kind of instant update, but high quality updates, right? You don't get the failures getting into production. Microservices. This is an interesting one, right? So there's a big question out there in terms of is microservices necessary for cloud? But let's say that microservices can be of varying different sizes, and but anyway, this idea of building applications and actually, so 20, 30 years ago we were talking about object-oriented programming and encapsulating parts of the application into objects, but fundamentally deploying those objects all together in one application that got deployed to production. With microservices, we're still encapsulating. There's still this idea of chunking up the application and getting multiple teams to build multiple things at the same time, but now deploying those things as individual applications in their own right, and then having that kind of infrastructure around them to support them and allow them to communicate, typically over HTTP APIs, RESTful APIs, that sort of thing. But this fundamental idea of building discrete applications and deploying them cheaply, actually, and automatically. You wouldn't build microservices if you haven't sorted out DevOps and continuous delivery, quite frankly. And then containers, making that easier again, and actually packaging up these applications and making them portable. Now, for some of the cloud things we were talking about, for instance, serverless and that sort of stuff, you could argue a serverless function or serverless lambda is a microservice. It's an interesting discussion to have. But it's certainly not a container, right? So containers are very, very important up to a certain point in our stack, probably 5 or 6. But beyond that, actually, we start to move past the idea of containers and servers and that sort of thing. But it's a fundamental piece for a good chunk of those cloud native stories that we were talking about. So deployment flavors and their characteristics. So as we were talking about this and we were trying to discuss within the team at Celent, what's the differences between these cloud models, and actually how do you spot something that's enterprise cloud native versus something that's extreme cloud native? What's the difference there? And actually you start to get some of these interesting views here, I think. Let's see if I can get some of the maybe draw on the screen a little bit. Grab the pen here a second. So I'll have the pen, please. So this is interesting for me, right? This line here. So my experience of enterprise cloud native is it's still coupled to this idea of actually having scripts, and there being an exercise, an effort involved in doing the upgrades, right? So once you're on premise, this is difficult, right? And by that I mean, what do I mean by on premise upgrades or updates are difficult? There are stories all over the insurance industry of people customizing their application, getting into a very specific environment, doing changes to it. So when the next version of the code comes through, actually there's some effort involved in doing that regression testing, and often that regression testing is manual. So there's some effort in there. There's effort in retraining people. So it's difficult. Once you start shifting up here, and actually, this automated script might apply down here in the sort of modern on-premise, but it's certainly more prevalent here. Then actually you're starting to automate some of that. So you're taking some of that good continuous delivery experience, good DevOps experience, and starting to automate that. It's becoming quite very interesting. But actually, as you start getting into sort of more cloud native models, it's much more likely to be evergreen. And by that I mean constantly on the latest version. So you're not looking at I need to do a big upgrade of my software this weekend, and we'll have 40 people in testing it. Actually, you just kind of expect it, like Google search or like some of your other assets. It just gets updated periodically, and you get used to there being small, regular changes, that sort of thing. You'll notice here on multi-tenant, much more likely to be multi-tenant the further up you go on the cloud native concepts. And actually you'll notice the code changes here. So for open source cloud native, most of the libraries there are talking about Java and .NET capability, much as you were starting to build down here. On-premise legacy could be RPG and COBOL and things like that. But a lot of the enterprise applications and things that large financial institutions are using tends to be Java and .NET. But actually, as you start getting up here and you start writing things like serverless functions, you're doing that in different languages. You might be doing it in JavaScript. Java still comes in there. You do get, so the Azure one is in their language, of course. But you get some different language starting to show up here. And actually, much more likely to be multi-tenant. As I said earlier on, the serverless applications, the code tends to be non-stateful. We can talk about that if you're interested. And actually, once you get past this point, so here, if we start to talk a little bit about API and ecosystem, I'm crossing it out, but never mind. API and ecosystem there. You've got the on-premise legacy, you've got integrations there. And by that, I mean, this is the old way of thinking, right? I've got an application and I want to talk to the car database for a particular territory, for a country. I'm going to write some code to build that in, right? Up here, we talk about being connected, actually. So the system exists in the cloud. It exists on the internet, shall we say. It's permanently there. And actually, so does the data source or the API for the car database in the country that we're talking about. So it's just simply connected. It's already pre-built, but actually it's also hooked up. There's no effort there. Now, hosted on the cloud maybe gets the connected. Maybe it's integrations. Maybe it's a mix of both. And this one might be a bit of a question mark. Enterprise Cloud Native tends to be thinking a little bit old, so maybe it's got integrations as well. But the idea is you're shifting up this Cloud Native one. It's connected to the ecosystem. It lives on the internet. Other things that also live on the internet are connected to it. That makes sense. Let's pull out a couple of others. So we talk a little bit about serverless, microservices, DevOps, containers. As you can see, maybe here up there, nano services, enterprise cloud native. They tend to talk about microservices. There's some interesting questions about what you think there. So some really interesting points here. Now, got multi-tenant in there. So interesting set there. Hopefully that you're following all of this and you can see past my head where all this is going. So the path to the cloud. This is really interesting, right? So some interesting questions. Do you want to do more work, or do you want to have a single platform and less work? Now this is really talking about this question of many clouds. Are you going to support many clouds, or are you going to support and be an expert in single cloud? So let's go back up here. So up to about this point here, we see that these can all be multi-cloud. Oh, he's going to try writing with the mouse. It's very illegible. Hopefully the guys doing the subtitles can type that better than I can. Anyway, so this tends to be multi-cloud, whereas actually up here we're getting into a cloud-type environment. So for a small vendor in a particular country, for instance, to demonstrate their expertise in the cloud, it makes sense for them to pick a cloud and become deeply coupled to it, deeply tied into it, and take advantage of all of the capabilities of that particular cloud. So for a small vendor, and actually for a small insurer, a mid-sized insurer, this is very, very appealing, right? We pick one of the clouds, we go deep on that cloud, and we do that really, 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 really well. For a multinational company, for a larger company with more capability, and who is worried about risk, who wants to have some control, if you like, ability to move it, this could be very, very important. Historically, and I would say it's only really been in the last year that it's been possible, historically it's not been possible to really adopt a public cloud in such a way that you can still leave the choice open as to which cloud you're going with. But efforts like the Cloud Native Computing Foundation and others allow us to build to a particular standard and know that we can pick and choose different clouds in order to deploy the infrastructure. Now, it might be that a particular insurer or a particular vendor wants to deliberately manage their infrastructure across multiple clouds. So some of my compute is in Azure, and it's cooperating with some of my compute in Amazon, and it's cooperating with some of my compute in China in Alibaba Cloud, and I've got some compute going on in Google for some part of my business, and they're all interoperating. That's still very, very tricky. I think there are some folks who are moving on that. Some of the open source capabilities are actually starting to provide a service mesh that can distribute across different clouds. It's a little bleeding edge. The real advantage of this, or the real discussion for now on many clouds versus single cloud, is might you want to operate some of your business on a particular cloud in one environment, but maybe in a different environment you're looking at a different cloud. And this is really for multinational firms, right? Or people that operate in different parts of the industry and want to take advantage of multiple clouds. I think for most part, much of the insurance industry are going down the single cloud route, but I think that's going to open up in the future. There are still insurers that are looking at this mixed on-off premise versus cloud only. Some of that is because of legacy issues, so they still have data centers and will continue to do so because the contracts are 5-10 years in length, so they need to make use of the data center, but they want to have that flexibility of the cloud as well. In some cases, for some insurers, the cloud isn't moving fast enough, actually. So you get environments where the adoption of GPU technology is about, let's say it's a year behind, I forget the exact figure. So actually there are financial institutions out there and some insurers who are interested in adopting the GPU capabilities quicker. So they're building their own infrastructure for that and swapping them out faster than maybe the cloud is in order to make use of some of that particular compute capability. Now that's kind of interesting variant of the on-off premise idea, but there is genuinely a kind of mixed on-off premise versus cloud only. If you go down a SaaS route for a core system, um, and it's in this kind of extreme cloud native route up here, this level 8, you're going cloud only, and you're going a single cloud only, and that's a decision that you're making. It's a good decision, but there are insurers out there who are making different decisions. And then we've got this idea of kind of, and these two are coupled, right? Multi-tenant and evergreen versus single tenant and maybe upgrade control. If you're going multi-tenant, everyone gets the same version of the software. It kind of implies you're on the latest version of the software. This idea of evergreen, constantly updated. And there, this is a cost play in terms of multi-tenant, and actually being evergreen is a culture decision, if you like. And it's interesting the two are coupled together. And then you've got single tenant, and then the opportunity. This is less coupled, right? You could be single tenant and evergreen, right? But this idea of you've got your own protected environment, and you choose when you do upgrades, you choose when you do things. That's quite tightly coupled. There's a really interesting discussion to be had there about if an organization is very tied to controlling these things and regulating when they go out, are they thinking in a modern way or not, and that sort of thing. I think these 5-6 trade-offs here help you to navigate what you might be thinking, right? I mean, if you've got a deep concern about going for a single cloud, and you're very concerned about being cloud only, and actually you prefer single tenant, that makes some decisions about this list, right? So if you recognize that something is an extreme cloud native or it's tied to a particular cloud, then you can start to see that if you don't want to be single cloud, if you don't want to be tied like that, you're cutting out this set of solutions, actually. So when you're selecting software, when you're looking at solutions in this space, put your early questions in there around these and then start to cut those out. Now there's some concerns there, right? Maybe the best solution for you right now happens to be one of those, but you'd rather be many-cloud or multi-cloud. And that's an interesting discussion to have, right? If you go deep and you become a partner with a particular single cloud-tied solution, but you'd recognize that in the future you want to be a multi-cloud organization, you have some options. You can talk to the vendor about their plans and work with them on their journey to becoming multi-cloud. That's a possibility. Or, and I would recommend this anyway, you look at how you get off that cloud platform, right? So before, and this is a little bit like signing a prenuptial agreement in a marriage. The idea is you work out how you're going to divorce before you get married. You work out how you're going to pull out of being in this relationship with a single cloud provider when something that's a better fit for what you want to get to comes along. It's good practice actually anyway when you're looking at a new system, when you're looking at a new vendor, to work out what the costs, the effort and the risks are in terms of coming off of the platform before you start putting anything on there anyway. But there's some key things there. But hopefully these 6 topics, these 6 trade-offs will help you navigate where you think you want to be. And actually, I think these 8 categories here, hopefully they'll help you navigate or at least understand the differences between organizations and get some sense of when everybody's saying we're all cloud native, you get some sense of what it actually means to be cloud native and which cloud native you want. I mean, that's the key thing here. So, thank you for your time. Hopefully, that's helped you, given you some tools for finding the right cloud model for you. And it is a personal thing, right? It is a particular insurer at a particular point in time requires different things. So what is the right cloud model for you right now? And then giving you some tools to help you find those sorts of tools, those sorts of solutions, that sort of software. And hopefully hopefully that gives you something on which you can start to build your cloud strategy in insurance. Thank you very much for your time today.